Hello, welcome back. Differential equations. Second order differential equations. Example 2. Solve the following homogeneous differential equation. Y double dash minus 3y dash plus 2y equal to 0. Initial conditions y0 equal to 1, y dash 0 equal to 0. Find the general solution and a particular solution. First, we need to find out a substitution. Here we will substitute y equal to c e to the mx in y double dash minus 3y dash plus 2y equal to 0. So we know y. Now we need to find out y double dash and y dash. So to get y double dash, we differentiate y with respect to x. So we get c m e mx, and if you differentiate this one again with respect to x, c m times m c m squared emx, c m squared emx. That's y double dash. Now we substitute y dash and y double dash in this equation. Now then we get y double dash equal to c m squared emx minus 3y dash 3 times c m emx plus 2y 2 times c emx. Now we can remove emx from this equation because it's equal to 0, so it's common term, and also c is a common term here. You can remove them. So then you will end up with 0 equal to m squared minus 3m plus 2. So you can factorize this one, m minus 1 times m minus 2. Therefore m equal to 1 or m equal to 2. M equal to 1 or m equal to 2. Therefore, the general solution is y is equal to c1 e to the m1x, m1 equal to 1, plus c2 e to the m2x, m2x equal to 2. c2 e to the 2x. That's the general solution. Now we need to use the initial conditions to find out the values of c1 and c2. So substitute y0 equal to 1 and y dash 0 equal to 0 in y equal to c1 e to the x plus c2 times e to the 2x, the one that we just now obtained. So if we substitute y0 equal to 1, we get right hand side c1 e to the 0 equal to c1 plus c2 e to the 2 times 0 equal to 0, c2 times 1, c2. And now we find y dash equal to, when you differentiate right hand side, c1 e to the x plus c2 times 2 times c2 e to the 2x. When you differentiate this term here. And now substitute y dash 0 equal to 0, y dash 0 equal to 0. So instead of x, you substitute 0. z1 e to the x e to the 0 plus 2 times c2 e to the 2 times 0 e to 0. This will lead us to 0 equal to c1 e to 0 equal to 1, 2c2 e to 0 equal to 1, c1 plus 2c2, equation 2. Now what we do is we subtract equation 1 from equation 2. Then we get 0 minus 1 is equal to minus 1. c1 minus c1 equal to 0. 2c2 minus c2 equal to c2. So that's first one we get. Now we can substitute this value in equation 2 to get c1. c1 equal to negative 2c2 if you take 2c2 to the other side, and then substitute for c2, which is equal to negative 1. So therefore negative 2 times negative 1 equal to positive 2, c1 equal to positive 2. Therefore the particular solution is y equal to c1 is equal to 2 e to the x